Alright, this is your Forces podcast. Make sure you fill in the notes as you follow along with this podcast. First thing we're going to talk about is what is a force. A force is a push or a pull on an object. So obviously it has to be on an object, but you can push it or pull it, and that's a force. Some examples of forces are friction, gravity, kicking a ball, pushing a shopping cart. Anything that involves a push or a pull, even if we can't see it, such as friction or gravity, is a force. Now there are two properties that every forces have. They have size and direction. What that means is that it's going to have some sort of magnitude or a size, and it's going to go in one direction. Forces act on all matter, and they can cause them to move by speeding up, slowing down, or changing directions. In other words, forces cause objects to accelerate. Remember, acceleration means to speed up, slow down, or change direction. So as I said before, all forces have a magnitude or strength or size and a direction. The way that we represent forces are things called vectors, which is just a fancy word for arrows. The length of the arrow is going to tell you the magnitude of the force, or how big it is. The bigger the arrow, the bigger the force. The longer the arrow, the bigger the force. The way the arrow points tells you the direction. It could be right, east, up, down, forward, north, left, right. Any of these things tell you a direction. When you draw a force, you're going to want to make sure that you include the number of the force, as well as an arrow showing you which way the force is acting. You also need to include the unit. For forces are measured in units called newtons, after Sir Isaac Newton. We show this as a capital N. So if we were to show a force of 5 newtons, we would need to draw a long arrow and have a number of 5 newtons. Notice the 2 newton arrow is a lot shorter, and then it has the number 2n next to it. This is how we show forces with the vectors. The thing we need to know about forces is combining forces. When you have more than one force acting on an object, you're going to want to find the total force acting on that object. That total force acting on the object is called the net force, the total. There's 2 ways you can combine forces. One way is when 2 forces act in the same direction. When they go in the same direction, you're going to add them together. In other words, it's like saying, I'm pushing a box, and one of you come and help me to push this box further. You're adding your force to my force. So if I have a force of 3 newtons and I'm pushing this box, and then one of you come and help me and push with a force of 2 newtons, you are adding your 2 newtons to my 3 newtons. Our net force is going to be 5 newtons, and the arrow is going to be pointing in the direction that both of us are pushing. Same thing with this example here. This girl is pushing the piano at 25 newtons, while this boy is pulling the piano at 20 newtons. To find the net force, all you do is add 25 plus 20. You're going to get 45 newtons, and the direction is to the right, since that is the direction that they are going. So if they're acting in the same direction, we add. So when they act in opposite directions, then they're going to combine by subtraction. This is like a game of tug-of-war. Let's say one team is pulling at 5 newtons, and one team is pulling with 2 newtons. In order to find the winner, you're going to subtract these 2 forces. So in this case, 5 newtons has the longer arrow, 2 newtons over here. 5 minus 2 is going to be 3 newtons. Now this next part is very important. The overall force will be in the direction of the greater force. Since 5 newtons was the greater force here, the overall direction of the force is going to be in the direction that the 5 newtons was going. So it'll be 3 newtons to the right, since 5 newtons was already going to the right. These 2 get canceled out. Same thing happens when you have a tug-of-war game. You have a big dog pulling at 12 newtons, and a little dog pulling at 10 newtons. They're in opposite directions, so we know that we need to subtract. 12 minus 10, big minus little, is going to give us a total of 2 newtons. That's your net force. The direction is going to go into the greater force. Since the big dog had the greater force of 12, we're going to say that the net force is going to the right. In other words, the big dog wins. Okay, so let's practice. I have 3 newtons going to the right, and I have 5 newtons going to the right. Since they are going in the same direction, we know that we are going to add these together. 3 plus 5 will be 7. When we do net force, we want to make sure we have the number, the unit, and also the arrow. Since the direction of these forces are going to the right, our net force will also go to the right. The next example, we have 2 newtons going down and 2 newtons going up. Since these two are going in opposite directions, we know to subtract. 2 minus 2 equals 0 newtons. When we have 0 newtons, there is no direction. We say that this thing is not moving. This next example, I have 2 newtons pulling to the left, and I have 6 newtons pulling to the right. We know that these are opposite directions, so we are going to subtract. You always subtract the big number minus the little number. We don't want negative numbers. 6 minus 2, you will get 4 newtons going to the right. Since 6 newtons is already going to the right, and that's our bigger force, our net force will also go in that direction. This next example, I have 3 newtons going to the right and 2 newtons going to the left. Again, we are in opposite directions, so we are subtracting. 3 minus 2, hopefully you're all going to say 1. We need our unit. And since 3 newtons is our greater force, our net force will also be going to the right. This next example, I have 5 newtons going up and 4 newtons going up. They are going in the same direction, so we are adding. 5 plus 4, you will get 9 newtons. And since they are both going up, our net force will also go up. We have 3 newtons going to the left and 3 newtons going to the left. They are moving in the same direction, so we are adding these forces together. 3 plus 3, 6, add your unit, and they're both going to the left, so our net force will also be going to the left. Our last example, we have 5 newtons going to the left and 5 newtons going to the right. They are opposite, you will subtract. 5 minus 5, we have 0, add your unit, which is newtons, and since they are 0, there is no direction. It's not moving. So what does all this net force mean? We actually have 2 types of forces. We have balanced and we have unbalanced. So when we have 2 or more forces acting on an object at the same time, we have to classify them as either a balanced force or an unbalanced. Hopefully you guys have picked up on things that are balanced probably has an equal amount of size, equal amount of force, whereas something unbalanced is unequal. Think of games of tug of war. If I have 2 kids on one side and 2 kids on the other side, let's say they're all equal strength, they're going to be a tie. This is not going to win. However, on this game, we have 4 people on this side and 3 people on this side. Let's just say everybody has the same strength. Obviously, the side that has the more people will win. This is not balanced. An unbalanced force creates motion, whereas a balanced force creates a tie. When we have balanced forces, we talk about not having a change in an object's motion. In other words, the object is at rest or not moving. Balanced forces are always equal in size, meaning that they're same strength, and opposite in direction. They also always act on the same object. When we talk about forces, we're going to be talking about things that happen at the same time at the same object, not multiple objects at the same time. When the net force is 0, this is when we know our forces are balanced. There is no motion. In other words, they cancel each other out, or there's a tie. For instance, if I have 5 newtons pulling to the left and 5 to the right, this ends up being a 0 Newton force. Notice how my forces are equal in size, 5 and 5, and they are in opposite direction. Because they are equal and opposite, the net force will always be 0. This is a balanced force. The same thing is happening right now as you're sitting in a chair. The reason why you don't fall to the ground is your weight pulling down on the chair, and the chair is pushing back up on you. If this did not happen, you would actually fall to the ground. This is an example of a balanced force. Unlike balanced forces, unbalanced forces do cause a change in motion. They can either change in speed, either speed up or start moving, or slow down or stop moving, or you can change its direction. All of these things are unbalanced forces. The net force of an unbalanced force is going to be any number greater than 0. In other words, it's showing us that some side is going to win or is going to move. In other words, this example, we have 5 newtons to the left and 10 newtons to the right. Since these are opposite directions, we know to subtract. 10 minus 5 is going to be 5 newtons. Since the 10 going to the right is the greater force, we know that the net force will also move to the right. This also happens when you have same direction forces. If we're pushing in the same direction, 20 plus 20, we know to add, and there is going to be a motion to the right, because that is the direction that they're pushing in. Anything that has a number for a net force is an unbalanced force. Now keep in mind, if something is staying still and we put a force on it causing it to move, that's going to cause this object to accelerate, speed up, or slow down, or even change direction. But it is still classified as an unbalanced force. Now what you will need to do is fill out the practice problems and wait to rotate to the next station.